from universities, 6% private consultants, and let's see, 2% from public lands agencies, 2% from the tribal government, and 4% from federal government today. It looks like from where you are joining us from, our majority of people, 33%, are from the Western U.S. We have about 30% from the Midwest, 20% from the Southeast, 5% from the Northeast, and we have 10% from others. So welcome to our potentially international participants today as well. Now it looks like most of you are joining us by your computer only, which means you are listening to us over the computer. If you do have any issues with the audio today, we would remind you that the phone number is in the top left-hand corner of your screen, and that if you do have audio issues, we would ask you to please call in. Sometimes the Wi-Fi will make the audio over the computer not work as great as it should, so that's your backup there. I'm going to go ahead and move us over to the presentation so I can give you a few more pieces of information before we get started. So a few more logistics for you. Our webinar will be an hour and a half long. It is being recorded and will be archived on our website within the week. For quality of this recording, as most of you know, your phones have been muted for our presentation. If you are listening by phone, we would ask you to please mute your computers, otherwise you will hear some feedback during our presentation. If there are any charts or pictures in the presentation that you'd like to see full screen, you can click the 4 arrows that point outward in the top right-hand corner of your screen today, and that will make the presentation itself full screen and get rid of all of the information along the bottom and left-hand sides of your presentation. At the end of each section, we will have some time for question and answers. You can use the chat pod on the left-hand side of your screen to put any questions in. Please feel free to go ahead and put those questions in at any time. When we do break for a question and answer period, I will go ahead back through the chat pod and read all of those questions out to Mark. So again, please feel free to put those in as you come up with them instead of just waiting until a question and answer section. At the bottom left-hand corner, you'll also see a handout pod. That has a version of today's PowerPoint slides in PDF. You're more than welcome to download those and keep those for your records. Any resource links that Mark provides will be in that PDF. And following today's webinar, you will receive 2 surveys. The first one will come out directly following this within the hour. Those surveys are what will allow you to get certificates of completion and CEUs for today's webinar. The second survey will come out 3 months later. That particular survey is going to ask you more information about what you've done with the information that you learned today, whether or not you shared that with a colleague, whether or not you've implemented any of the solutions that Mark has shared with you. So the survey link you can see on your screen right now, again, also available in that handout in the bottom left-hand corner. Just in case the survey ends up in your junk mail and you're not able to find it, we do like to provide you with this link now. The survey will close 2 weeks after today's webinar. You can expect your certificates and CEU forms in about 3 to 4 weeks. I will mention that the last 2 webinars are behind on this, and that's due to waiting for Montana State University to provide us with the forms. They've had some staffing changes, so that is a little bit behind. You should expect to see all of those next week. You can return the CEU forms to continuinged@montana.edu and not to the Safety Center, as that is run through our Montana State University program. If you do need to ever show that you have obtained these CEUs, you can request a verification of completion form from Montana State University as well. And I'm going to show you that on the top left, you can see the registration form that will be coming to you, and the top right is what the verification of completion would look like if you do request it. Again, on that top left course registration form, it will ask you about funding. These are completely free. There is no cost to you for this. Today's presenter, we are very proud to have Mark Doctor from the FHWA Resource Center here with us today. Mark is a Senior Safety and Design Engineer with the Federal Highway Administration's Resource Center. He is responsible for advancing innovative and flexible design and safety practices on a national level in the areas of geometric design, intersection safety, innovative intersections, freeway interchange design, and performance-based design solutions. Mark received his bachelor's degree in civil engineering from Clemson University and his master's degree in transportation engineering from the University of Florida. Today, he's going to be talking to you about how to understand how to effectively identify intersection safety issues in rural areas and how to select low-cost countermeasures that address them. We have a few learning outcomes that go with this goal. They are to understand the concern with rural intersections, to list important references for information on rural intersection safety countermeasures, to identify intersection safety concerns from available data sources, to analyze crash patterns and assess current roadway conditions to identify contributing factors, and lastly, to select appropriate countermeasures for safety problems identified. And at this time, I am going to turn the presentation over to Mark. Mark?
All right, Jamie, thank you. I am having a little bit of technical difficulties, so I'm not going to be able to advance the slides. So if I can ask for support on your end to help advance the slides, I appreciate that.
Sure.
And I'm going to try to log in on a different device when we go to a break. So yeah, if we can advance to the next slide, please. All right, great. So the concerns with rural intersections, and if you could please scroll through the animation on this slide as well. We have about 7,000 fatal crashes at intersections each year in the U.S., and about 70% of those are at unsignalized intersections. And if we look at the urban versus rural split, you see about half are at rural intersections with higher speed, and it's usually defined as posted speeds over 35 miles an hour. So certainly rural intersections, especially unsignalized higher speed intersections, are a definite safety concern. If you could please advance. And the concerns, since high speed rural areas, if you keep advancing to the next slide, please. Obviously, local agencies are a big part of the solution to helping drive down the numbers. And if you were at the webinar that that the center hosted last month, a fantastic webinar that talked about the road to zero, and you heard the speakers talk about doubling down on what works, and the National Safety Council on the road to zero, and the strategy of applying countermeasures that we know works, doubling down on what works. We have this body of evidence of ways to help improve safety, and that's kind of what we're going to present today. So if you could advance to the next slide, please. So what we're going to talk about, some useful resources, in particular those that are free. Can't beat free, right? And then I'll talk about a simple process for improving rural intersections with an emphasis on lower cost countermeasures. But we'll also talk about some of the more expensive countermeasures. If you happen to get funding from a rich uncle or an agency, a state agency or grant, that would be great. So we'll talk about that as well. And Jamie, while you're bringing up the first poll pod here, I am going to log out and log back in.
Sounds perfect. So we have come to our first question and answer section. If you do have any questions, they can go in the chat pod on the left-hand side. We will have 4 of these question and answer sections for you. We do have a question for the audience at this point, though. So that first question is, why is intersection safety of concern? There are nearly 7,000 fatal crashes occur at intersections each year. About 70% of fatal intersection crashes are at unsignalized intersections. Almost half of fatal intersection crashes are at rural intersections with posted speeds over 35 miles per hour. All of the above, none of the above, or I don't know, I don't remember. We'll give everyone just a few seconds to go ahead and fill that out. Looks like we have still just a little bit of movement. I'm going to give everyone another second, so get in your final answers. Okay, perfect. So it looks like about 93% of you got this correct. It is all of the above. And Mark did go through all of these on one of the previous slides. I'm hoping, Mark, it looks like you might be back into the webinar.
Yep, I'm back in the room, so hopefully I can advance the slides now.
All right, I'm going to move us back over to the presentation, so hopefully you'll be able to go ahead and do that.
And thank you for that poll question. And we start off with an easy question, right, Jamie, and build up to the tougher ones.
Absolutely. All right, we are all set for you. Why don't you check and see if the arrows will work for you now?
All right, very good. So we'll get into talking about some of the important references. So very good. I'd like to start off with what I think is a very comprehensive document that should be of great interest to a lot of the webinar participants today, and that is our FHWA Safety Toolkit, Improving Safety on Rural, Local, and Tribal Roads. It includes a step-by-step process targeted for local agencies and tribal practitioners, and it really walks through the process of how to conduct a safety analysis to identify your safety issues, look at countermeasures, and start to develop an implementation process. So a very thorough and comprehensive document. And then to narrow down specific to intersections, we have our FHWA Intersection Safety Manual for Local Road Owners. And again, the emphasis on issues more common to rural and local roads, and good information with regard to countermeasures and evaluating the treatments. And then a particularly useful resource is a collaboration between FHWA and the Institute of Transportation Engineers, and it's our Unsignalized Intersection Improvement Guide. And this is a web-based resource. It's not a hard copy document, and it is available for free. It's available for everyone. You don't have to be an ITE member. It is hosted by the ITE webpage. So I encourage everybody to please check out the Unsignalized Intersection Improvement Guide. And a lot of what I'm going to talk about today actually comes directly from this web-based document. It is also very comprehensive, and the focus on unsignalized intersections, not just rural, but also in urban settings. And the intent is to provide very practical, easy-to-use guidance, practitioner-focused, and it does also include operational issues, maintenance issues, even a little bit dealing with law enforcement, and targeted strategies to improve safety and accessibility for all users. And one of the key goals of the improvement guide is this understanding that when we get down to some of the local agency levels, a lot of times local agencies may not have a full-time dedicated traffic engineer on staff, or the engineers that are on staff, they may be juggling many different needs, many different priorities. So this is intended to almost serve as an extension of staff for perhaps agencies that don't have a very large engineering staff, especially a traffic engineering staff. So here's a shot of the web page from the improvement guide. It's broken down into two parts. It's got the informational part and then the toolkit. And in the informational part, we'll cover a good deal of what's in there as we continue on in the webinar. And another important resource from the Federal Highway Administration is our brochure on roundabouts for rural highways. And a lot of folks may think that roundabouts and rural higher speed approaches may not be a good mix, but actually that's a fantastic treatment for many of the common safety problems that we experience on rural higher speed roadways. And you can see in the brochure the picture. We'll talk more about this, but really I think one of the ingredients to the success of rural roundabouts is that elongated splitter island. And we will come back and talk about that in a little more detail as we get into some specifics later on. And then another guide that I want to make you aware of for all the information on roundabouts, the best reference that's currently available would be the report from the National Cooperative Highway Research Program on roundabouts, the informational guide, second edition, the second edition being an update of the original FHWA publication on roundabouts. And this is also available electronically, free of charge, and it's a comprehensive guide on the knowledge that we have with regard to roundabout design and operations. And not to leave out signalized intersections, there's a great guide, an informational guide from FHWA specific to signalized intersections, and that is in its second edition. So that was recently updated and expanded upon and covers a wide range of treatments, all the way from simpler, lower cost measures all the way up to perhaps things applicable to higher volume intersections. And that is also a free publication available from FHWA. And the Unsignalized Intersection Improvement Guide also includes a listing of other resources. So I covered some of the important references and resources, but if you go to the Unsignalized Intersection Informational Guide, there's actually a component of that walks you through a tremendous number of other references, intersections, and on other topics, including non-motorized user information. So that's kind of a run-through of the important informational guides and resources that are out there and that are free of charge. So I'll turn it back to Jamie for our next poll question.
Perfect, thank you. And one more time, we do have that chat pod over on the left-hand side. If anyone has any questions, you can go ahead and type those in there. Our second poll question for you, also a fairly easy one. Which of the following resources should I have in my intersection safety toolbox? Improving safety on rural, local, and tribal roads, intersection safety, a manual for local rural road owners, the Unsignalized Intersection Improvement Guide, NCHRP's Report 672, Signalized Intersections Informational Guide, the Roundabouts Brochure, all of the above, none of the above, or I don't know, I don't remember. Does look like we have a few questions coming in, so I'm going to give everyone a few seconds to fill out this poll question and some time for that question to come in the chat pod.
And it's encouraging that nobody says none of the above, or I don't know and I don't remember.
Okay, I've gone ahead and ended the poll question and broadcasted the results for you, Mark, if you'd like to discuss them.
Great. Yeah, so it looks like just about everybody said all of the above, and that is fantastic. I think in many ways they all are very important resources and good things to have in your intersection safety toolbox. And the best thing of all is probably the price. Those are all free resources. They're all relatively new and fresh, and I think very valuable in their specific ways.
We do have one comment that came in for you, and they say they do have a roundabout in rural Iowa, and it's functionally well, but they need to design for snow a little bit better. Do you have any suggestions or thoughts on the design of roundabouts for snow?
Interesting. So it'd be nice to know a little bit more information. Is it with regard to storing the snow? Many agencies feel like the plowing itself, the actual ability to provide winter maintenance is not too problematic for roundabouts, but sometimes it is an issue with Sometimes where do you push or store the snow, especially if it's going to be a long winter? So perhaps maybe they can dial in. And also put in a plug for the upcoming webinar in July that the Rural Safety Center is going to be hosting, and that will be specific to rural roundabouts. So perhaps we can even get you some more information about any type of snow plowing issues that you may have for rural roundabouts. But again, July, a webinar coming up on rural roundabouts.
Perfect. Thank you. I appreciate you doing that plug for us as well. The question did come in, a little bit more information for you. It says the winds create a snow wrap. The design is concave and not convex.
Whoa. Okay. I'm going to have to think about that one.
I do believe we also have Hillary on the line listening in, and she will be our speaker in July. So hopefully, Hillary, if you're listening, you can possibly discuss that a little bit more at our next webinar. Okay, Mark, we're all set for you to go ahead for the next section.
All right, very good. Yeah, we'll make sure that Hillary tries to address those. So, yeah, stay tuned for the next webinar next month. Very good. We always have a teaser. So I'd like to get into a simple process, a 5-step improvement process for intersection safety, and starting off with identifying your problem intersections. And agencies should have strategies to monitor their intersections as well as the entire roadway system to determine where improvements are needed. And this information actually comes from the Unsignalized Intersection Improvement Guide, and it gives a little information in there, not to concern anyone too much or scare anyone too much with regard to tort liability issues, but yet that is an issue for most folks, and the guide does address it a little bit and just kind of cautions agencies that simply looking the other way or claiming ignorance is not the best defense against tort liability. And the guide does give some information and talks about that if an agency, even if you don't receive explicit notice of a concern or a problem, there's a little bit of information in there that talks about the idea of a constructive notice. So if a problem does exist or if it's existed for some time, just a caution that agencies could be found with an issue with regard to constructive notice. So looking the other way, certainly not a good strategy. So to help agencies identify problem locations, there are many ways to do that. Certainly if we have crash data and the historical crash data looking back 3 years to maybe 5 years worth of data to kind of see where the issues may be happening, if there are any particular spots that are starting to stand out in terms of crash locations, as well as just systemic monitoring of your system by your staff, by agency staff, things that are observed maybe during routine maintenance activities or just driving around the area. And of course, there's notification by the public if you're getting complaints, phone calls, emails. Some local agencies include online reporting systems where people can enter questions or potential concerns online with geographic information tied to that. And also from law enforcement, from your local law enforcement, from police officers during patrols. And oftentimes the police have great information with regard to where perhaps some safety issues are happening. There are good eyes on the road that are out there. But to get crash data, each state does have a repository of crash data, different ways to try to get that information. Different states have different systems, but in all cases that there should be an opportunity for local agencies to be able to get information on crash occurrences in their area and paying attention to the conditions under which the crash occurred. There's a lot of good information that could be found with regard to whether the crashes are happening during a certain period of the day, like at night, or during inclement weather. The type of crashes can be a good indicator, whether it's rear-end collisions, angle collisions, sideswipe collisions, basically looking for patterns. And so state DOTs can oftentimes help local agencies with their crash data needs. So a suggested practice is to also develop a good relationship with your local law enforcement officials, the folks that actually go out and do the investigations, that prepare the crash reports, and getting perhaps information even before the process takes hold, where all these reports make it to a central database. So possibly fostering better cooperation and timeliness by reaching out and trying to establish good relationships with your local law enforcement agency. And the Unsignalized Intersection Informational Guide, that's the UIIG, includes links to several resources that can be helpful to help you analyze crash data. 3 to 5 years worth of data is preferential. Looking at the crash frequency alone, that's just the number of crashes that have occurred at a particular intersection over a period of time. It's only part of the issue, because it's also good to account for the exposure. And the exposure can be things like the traffic volumes. We would expect that on higher volume roadways or higher volume intersections that we would have more crashes, just because there are more cars going through the intersection or on the facility. So the crash rate helps account for that. Crash rate in the case of intersections can be the crashes per million entering vehicles into the intersection. So if we just looked at crash frequency alone, oftentimes it's the higher volume intersections that keep showing up as perhaps the problematic intersections, whereas if we account for volume or exposure, the crash rate can be a better indicator. So when looking at multiple intersections within your jurisdiction and trying to prioritize locations for perhaps some funding for improvements, crash rate can generally be more useful. Let me give you a little example here. So if we looked at two locations, and we'll call them intersection A and intersection B, and if we look just at the total number of crashes, so these could be crashes per year or total number of crashes in a 3-year period, well, they look pretty comparable, and actually intersection A has a few more crashes, so we might think that intersection A should be our higher priority. But then if we account for traffic volumes, and intersection A is at a higher volume facility, actually more than double the traffic volume compared to intersection B. So if we applied a crash rate, well, now looking at the crash rate, and that's measured as the number of crashes per million entering vehicles, so it does account for exposure. Well, now intersection B clearly looks like it might be the better choice for implementing some improvements. So crash rate can certainly be well worth the effort to try to compute and to compare when we're doing a screening analysis of our intersections. So here is how the crash rate can be computed. It's really not that complicated. The formula is there, and you probably have this information if you have the total number of crashes and you have a fairly recent count of traffic volumes. It is possible to look at screening by way of a crash rate. And then another step or strategy is systematic monitoring, and that's basically going through all of the intersections within your jurisdiction over a certain period of time. Now, depending upon the size of your agency and the number of intersections you have, whether it's a 2-year cycle, 3 years, or more, will depend. But basically going through and looking at what is available and documenting what or when the intersection was looked at and the potential issues. Another way is just ad hoc monitoring. So if you can't go through on a systematic basis on a regular time period, perhaps just covering what we can, when we can, on an ad hoc basis. And then relying on the public. And one of the items in the toolbox portion of the Unsignalized Intersection Improvement Guide is a sample form, a citizen traffic service request form that can be used as a template to capture information from the public, which is also useful in going through the system and assessing for potential issues. And law enforcement. Certainly reaching out to law enforcement, they have a keen awareness of the issue, and officers often can also serve as eyes to help supplement your own staff and maybe report things like a damaged sign or signal malfunctions or other issues that may be going on in your system or network. And these, whatever source of information that you have or could get, the toolkit within the Unsignalized Intersection Improvement Guide has a downloadable Excel spreadsheet-based inventory, and it is a way for an agency to very simply and easily start to build a database or a catalog or inventory of their intersection data and conditions. And so this work has already been done for you. This is a free tool that you can download and get a jump start on basically creating and populating a intersection assessment and inventory database. So that was step one of identifying your problem intersections. And once the problems have been identified, the next step is to start analyzing or looking at those locations and trying to characterize what the problem might be. So this is getting into the analysis. So we've become aware of the potential problem, and the next step is to try to figure out what might be contributing to these safety issues. And there's two activities that can go into an analysis. One is looking at the crashes themselves, the historic crash data, and then the other is going out and doing a site review or an observation. So for the crash data, looking for any patterns or anything that stands out, certainly looking at the crash types, and if there's an overrepresentation of a certain type of crash, or perhaps the conditions under which the crashes are occurring. And to help in this regard, a collision diagram is very, very helpful. And a collision diagram basically, say for an intersection, it's a graphical way of summarizing the data. So taking the crashes and listing them by the crash type. So for example, angle collisions or rear end collisions, where they happened, when they happened, the directions of travel, the approximate locations or time of day. It's very, very helpful for trying to see those crash patterns. And then going out to the field, going out for a site review and an observation. Yes, it's great that we have all of these online tools where we can see photos that were taken, but it's really no substitute for going out on a site visit. You'll be amazed at what you can pick up by actually visiting your site, going out to the intersection. And go out during different times of the day. Go out at night. Things are completely different at night. Go out during the rain. I know it sounds tough, going out after hours, going out during bad weather, but it is really valuable to get an understanding of what is happening. And looking at the intersection or your roadway during different times of day, look what's happening perhaps when school is letting out or going in So there's no substitute for an actual site visit under differing conditions and differing times of the day. And then another great tool or strategy is a road safety assessment, an RSA. And an RSA, in its purest form, would be a formal assessment by an independent and multidisciplinary team, a group of individuals that perhaps are looking at this intersection for the first time or from a fresh perspective. A lot of times we become blind to things we see on a routine basis, and we can actually miss the obvious. So having an independent group go out there can really be very, very valuable. So for more information on road safety assessments, the FHWA actually has a web page with great information about conducting RSAs. And putting the two together, the crash analysis with the field observations, is really valuable to helping identify the potential problem type. So let me give you a hypothetical example. If we had a location or an intersection and looking at the crashes that are occurring, if we see a pattern of rear-end collisions at this location, so perhaps we developed a crash diagram, and that became apparent from the crash diagram. And then coupling that with going out into the field and observing what is happening. So observing that perhaps left-turning vehicles are slowing down, maybe even to a complete stop, waiting for a gap in oncoming traffic to make the left turn, and perhaps blocking the through lane while they are doing that. And so a potential problem would be the lack of a left turn lane. So the crash analysis with the field observations can really help you make a more informed decision about the potential problem. And the unsignalized intersection informational guide even gives you a starting point. It describes 10 of the more common problems typically experienced at unsignalized intersections. And I apologize, I am having a bit of a delay in the slide advancement. Perhaps, are you seeing the slides advance?
It looks like right now there are some pieces popping up onto the slide. Are you seeing those?
I must have a delay in my screen. So I'm sorry. What are you seeing right now, Jamie?
No problem. So it's the now we are on the toolkit screen. The previous one was the fact sheet screen, and it has 5 black boxes on either side that just popped up.
All right. Well, again, I apologize because I may be locked up here. All right. So I guess, Jamie, I'm going to have to ask if you could advance the slides, please.
Absolutely. Just let me know which one you would like to start on.
All right. Yeah. Bear with me one moment, and maybe I can get this to catch up. But if not, so again, if you could tell me what slide you're currently seeing, Jamie.
The treatment fact sheet PDFs.
Ah, okay. All right. Excellent. Excellent. Yeah, that one does have some complicated animation to it. So in the unsignalized intersection informational guide for each of those treatments, there is a fact sheet. And Jamie, if you could just kind of scroll through all the animation to highlight all the pieces of those fact sheets. And this is just an example. Okay, have you got them through?
Yep, we're all set.
All right, very good. So it is a fantastic reference, a fantastic resource, and starting with the problems and then going to the potential countermeasures. So for each treatment, there is one of those PDFs. And Jamie, if you could advance to the next slide that shows the screen capture of the toolkit. And the toolkit, again, this is the Unsignalized Intersection Informational Guide. We talked about the downloadable Excel spreadsheet and also the form for tracking inquiries that come in from the public. And one of the other things that the toolkit also has is a opportunity to look at selecting treatments and doing so by way of a search and the opportunity to apply filters. So if you advance to the next slide, it'll talk about the treatment alternative filters, and it includes things like whether you're in a rural, a suburban, or urban area, the type of roadway, and also if you have information regarding the types of crashes that may be occurring on that roadway. So the filter is another great way to help narrow down. And then on the next slide is the treatment alternatives matrix, because it also breaks down the treatments by way of whether they are modifications to traffic control devices, whether they are more extensive geometric improvements, or whether they deal with the issues like the pavement or the shoulder. A lot of times it may be an infrastructure-related issue, things like reduction in friction on the approach to the intersection, perhaps a bleeding of the asphalt. So all of these things that could be contributing factors, and so the treatments alternative matrix helps guide you into perhaps a proper choice. So if you could advance to the next slide, where we have an example problem of a minor street stop-controlled intersection. So in this case, drivers on the major street do not stop, but on the minor street they do stop. And if the problem is drivers on the minor street are apparently not observing the stop sign, or maybe they don't expect the stop sign and are running through it, some possible options: enhancing the advanced signing or pavement markings to supplement the advanced signing, like a stop ahead or transverse bars, perhaps rumble strips, or doubling up on the stop sign, putting them on the left side, or strategies to enhance the conspicuity of the stop sign. And if you advance to the next slide, we just see an example of an oversized advanced warning sign with flashers. So basically strategies to make the intersection more visible, make it stand out, bigger signs, warnings, and doing it in an effective way. So maybe not every intersection requires mammoth signs and flashers, but certainly those where problems exist. And on the next slide, it summarizes the listing of enhanced sign conspicuity methods that are covered in the Manual on Uniform Traffic Control Devices, the MUTCD. And in Section 2A15 of the MUTCD, it goes through these 11 different strategies that are possible and could be utilized to help signs and the intersections become more visible. And on the next slide, you'll see a photo of an example of an overhead treatment. So not just doubling up on the stop signs, but putting one overhead, supplementing it with a stop beacon. There's really all kinds of strategies and combinations and possibilities. It's certainly not a one-size-fits-all approach. And if you go to the next slide, it makes reference to an important part of the unsignalized intersection improvement guide, and that is the part that is on what does the MUTCD say. Again, the MUTCD, the Manual on Uniform Traffic Control Devices. So this is a quick way of getting to the sections within the MUTCD that can help make sure that what you're proposing to implement, whether it be enhanced signs or pavement markings or pedestrian traffic control devices, that it is consistent with the MUTCD. So I find that this "what does the MUTCD say" part of the guide is very, very important. So moving on to the next step in our 5-step improvement process, into step 4 on selecting or implementing cost-effective treatments. So in step 4, where we're selecting or implementing treatments, and in the next slide you'll see that whereas in step 3 we identified perhaps the treatment options or multiple treatment options, this step focuses on looking at what is cost effective. And a lot of agencies use a benefit cost analysis, and if you just advance through some of the animation on the slide, it shows the estimated benefits and estimated costs as being the two sides of this balance on the equation. For estimated benefits, certainly looking at what expected crash reduction are we likely to have, or if it's an operational improvement, the benefits in mobility, and comparing that to the cost, not just the implementation cost, but also thinking about the long-term maintenance issues and looking at it from a life cycle cost analysis. So on the next slide, I want to point out another important reference, and that is the FHWA's Safety Benefit Cost Analysis Guide. And this is intended to be a easy to apply, easy to understand, user-friendly reference to walk you through how to conduct a site-specific or perhaps a systemic analysis of the benefit cost of implementing various treatments. So a good reference and another good tool for your toolbox. And on the next slide, where we talk about cost estimates and things like the Unsignalized Intersection Improvement Guide, the guide is relatively silent when it comes to costs. It does talk about the relative cost, but we do know that costs for even simple things like installing a sign can vary greatly around the country. So when developing cost estimates, we do encourage you to use your local agency information and also to consider the life cycle costs associated with it. And then when it comes to estimates, when we talk about estimating the benefits, on the next slide you'll see the Crash Modification Factor Clearinghouse. And the Crash Modification Factor Clearinghouse is another great reference. It allows you to do an online search for information about the expected safety improvement, or by implementing a treatment, what do we expect the crash modification to be? And so we can apply a dollar value to a crash savings, and an expected crash reduction by implementing a treatment can be derived from the Crash Modification Clearinghouse. Then in the next slide, we talk about another approach to implementation, and that is the systemic approach. And since many treatments are low cost, the potential exists to apply them on a systemic approach, and this is particularly advantageous when crashes are occurring in a widely scattered area within your jurisdiction. And this is fairly common in rural areas. You may not see a crash hotspot, but you may see crashes that are kind of spread out among your area. So this is an opportunity to be more proactive and implementing features or improvements based upon certain risk factors. So even if a crash or a severe crash hasn't occurred there, we know that perhaps the conditions, and it could be based upon traffic volumes, it could be based upon sight distance, it could be based upon a whole host of things, and then implementing countermeasures accordingly. And in the next slide, you'll see one of the FHWA proven safety countermeasures, and it deals with the systemic application of multiple low-cost countermeasures at stop-controlled intersections. And there are different strategies that could be applied, but typically it's a matter of some simple lower-cost enhancements. It could be things like doubling up on the signs, putting one on the left-hand side, putting a retroreflective sheet on the signpost. It could be supplementing the advance warning signs with a pavement marking, like a stop ahead word marking you put on the roadway itself. So all of these things in supplement with one another can really help improve safety at intersections. So that was a step 4. And then moving on to step 5 in our improvement process, and that is monitoring the treatment's effectiveness over time. And monitoring effectiveness over time, that the process doesn't end at implementation, and it's important to try to determine if the condition has truly improved. And we can do that by looking at crash data, perhaps getting perspectives from law enforcement, or if it was an individual who notified your agency of the problem, perhaps following up and seeing if what has been implemented actually did improve. So there's another example and for monitoring effectiveness over time. The next slide shows the information from the FHWA's Intersection Safety Manual for local rural road owners. And if limited data is available, sometimes just a simple before and after analysis of the crashes. So moving on to the next part, I want to get into talking a little bit about intersection forms and traffic control options that we have. So when it comes to intersection forms, we'll start off with the most basic, and that is no control. And this may happen at a very low volume road, perhaps a rural roadway or maybe a residential roadway, and lower speeds in a residential type roadway and a rural highway. Hopefully we've got good sight distance, so adequate sight distance. And even at an uncontrolled intersection, it really is a implied yield condition. Most state vehicle codes have the control is basically yield to the vehicle on your right, or if vehicles are approaching the intersection at the same time, or yield to whichever car would arrive at the intersection first. So there are some of those still out there, and in some states, in many states, they have very few of these no control intersections. So then moving on to what the MUTCD says, there is a little bit of guidance in section 2B04 of the MUTCD that talks about when a yield or stop sign should be used, and gives a little bit of information, and especially if we're in a signalized area, there's certainly not that expectation to not have any type of traffic control. And the MUTCD talks about yield or stop signs should be considered when we have traffic volumes that are more than 2,000 units per day, so that includes the combined volumes of vehicles, bicycles, and pedestrians, or where we have sight distance issues or a crash experience that would imply the appropriateness for putting in a positive control. So yield control is a possibility, and certainly we see yield signs for roundabouts, but outside of roundabouts, there are some applications where perhaps it's not required to always stop, and this could be perhaps at a T intersection where the approach coming into the top of the T may have yield control. So we could see these at residential type streets. So then moving on to stop control. The MUTCD does provide some guidance on stop sign applications for the minor street. This is guidance, unlike a traffic signal warrant. This is a guidance which is good, however, for practitioners to think about the appropriateness of stop control. And the MUTCD talks about when the vehicular volumes exceed 6,000 vehicles per day, or where there's a crash indication, or where there are issues being observed and stop control is appropriate. And then in the next slide, I want to point out a very impressive look at some of the more advanced intersection safety technologies that was done in Minnesota. And so the Minnesota DOT, and this is a published report that is available to look at, and it looks at the effectiveness of some of these enhanced features and providing LED outlines or a flasher on the stop signs, and then on the side or on the major highway that doesn't stop, the warning signs of traffic approaching or traffic entering. And these are still, even though it gets a little more expensive for those types of detector-controlled devices, still relatively low cost and very impressive in terms of the safety benefit. So we're seeing more applications of these more advanced intersection conflict warning systems. So I just want to point that out. And then the next slide, we get into the all-way stop, the multi-way stop. The MUTCD does provide some guidance there with regard to traffic volume thresholds for perhaps when an all-way stop or multi-way stop would be applicable. And then lastly, traffic signals and traffic signal warrants. Traffic signal warrants, you'll see this text in bold because it is a standard in the MUTCD. So the decision to install a signal is one that should not be taken lightly. And the warrants walk you through the important considerations for putting in a signal. And in the next slide, I do like to point out this particular section from within the MUTCD that does acknowledge the advantages and disadvantages of traffic signals, and makes the statement that even though traffic signals may be considered a panacea for all of our traffic problems and intersections, it's really not the case. And in some instances, we've actually had traffic signals installed at locations where perhaps they've been the source of problems and challenges. And so traffic control signals should be properly considered before implementation. And the photograph that you'll see in the next slide kind of gives it away in terms of the key issue we oftentimes see on rural intersections with high-speed approaches. Putting in a signal on a rural high-speed approach, the skid marks in advance of the intersection tell the tale, and it's very, very common. So high-speed rural roadways and signals may be even more of a challenge. So in the next slide, we want to talk about rural roundabouts and how well rural roundabouts have functioned, and the great safety benefit. And roundabouts are the safer intersection choice under a wide variety of conditions, including rural intersections. And advancing to the next slide, you'll see the elongated splitter island, and I think this is an important piece of an important ingredient to the success of rural roundabout safety. One of the common challenges with a rural intersection, whether it be stop control or a signal, and I'm sure you can imagine this, if you're driving down a two-lane rural roadway and maybe it's a very straight alignment, and a lot of times drivers just become inattentive. They're maybe not asleep at the wheel, but maybe they're not fully awake either. And so blowing through the stop sign or blowing through the signal can be a very common problem. Well, if you look at this photograph of the approach to a rural roundabout, you see the splitter island, the elongated splitter island. If we were to take that same scenario of an inattentive driver approaching an intersection, and maybe they didn't see the advance warning signs for whatever reason. And at this type of rural intersection with a roundabout as opposed to just a stop control or signal, well, the first thing they're likely to hit would be the end of that splitter island. And the splitter island could be several hundred feet in back of the roundabout. If it was me, if I was that inattentive driver, rather than blow through a stop sign, T-bone somebody, injure somebody, or myself get injured, I would rather take my chances by hitting the curbing of that elongated splitter island, possibly giving myself enough opportunity to regain control of my vehicle. So even with that negative scenario, we could perhaps change the outcome by having that benefit of the elongated splitter island. And even if it's not a roundabout, I would think that there's benefit to channelization to splitter islands at any type of rural intersection. It just alerts the driver to the fact that something is different, something is changing, and perhaps getting the driver to slow down on the advance to the intersection. So in the next slide, you'll actually see a plan sheet of a rural roundabout. This one from Washington State. And if you advance the animation, you actually see the blow up or the enlargement of that splitter island. And advancing the animation some more, you'll see the radii of curvature, and it's actually successive reverse curvature. So you see the first curve there on the approach, about 500 feet, coming into a 300-foot reverse curve in the other direction, coming into the final entry into the roundabout. So it basically uses the curvature, the geometric design, to slowly bring speeds down to an appropriate entry into the roundabout. I think the successive reverse curvature, the elongated splitter island, really helps contribute to the success of rural high-speed roundabouts. And in the next picture, you'll see an example, one more example of a rural roundabout, a good example from Washington State with the elongated splitter island. And these come in different designs as well. There's no magic number to a particular length or the curvature. It's the concept, and that concept being gradually bringing speeds down, inducing some deflection, some reverse curvature, and helping contribute to improved safety. And so moving on to more about the geometrics, a very common problem on divided highways, especially divided highways with open medians, and advancing through the animation, you'll see how the far side right angle collisions are usually the issue, usually the concern. As drivers, we're pretty good about judging gaps on the near side, but less so about judging for gaps on the far side. And so one of the common problems we see is the pattern of far side angle collisions. So a good strategy for that is the restricted crossing U-turn, also known as a J-turn or a reduced conflict intersection, also goes by the name of a super street. It's an at-grade intersection with directional medians so that the minor road traffic must turn right and make a U-turn to come back if they wanted to make the left turn maneuver or the crossing maneuver. Now from the major street, all of the movements are normal. There's no difference in terms of what the driver sees from the major street. The only difference is the minor street, where all traffic makes a right turn. And advancing to the next slide, where we see the animation of traffic coming from the minor street, making a right turn, and then coming back to make a U-turn, and assuming they didn't want to make the right turn, if they wanted to make the left or the crossing maneuver, coming back by way of a U-turn. So it takes away that far side angle collision. It basically breaks up the driver decision points. it makes it simpler for drivers to judge for gaps and make a safer crossing. And in the next slide, you'll see the traffic conflict points. The RCUT, or restricted crossing U-turn, has fewer conflict points, but in particular, it has eliminated those far side angle collisions. And the research that has been done on these have been very, very impressive. There's a study out of North Carolina that looked at 93 unsignalized RCUT intersections across the state with very impressive crash reductions in the order of magnitude of 88% for reducing the severe and fatal crashes. And let's see, Jamie, let me check in with you to see if things are still progressing well with the slides.
Yep, they all look great. We're on the North Carolina study one now.
All right, perfect. Thank you very much for checking that. I apologize for having to fly blindly here, but things are doing well. And Jamie, stop me when we get to a poll question. I think we've got a little bit more to talk about here with the J-turn and then a poll question. So moving on, I think there's a photograph that shows the issue of how do we handle trucks and designing for trucks to make the U-turn maneuver. And it's done by way of a bulb out, or a loon, L-O-O-N is a term that some agencies use. And basically it is accommodating the needs for the swept path of a truck to be able to make the U-turn maneuver. So yes, it is possible to even design for oversized vehicles with the U-turn maneuver. And so I think we've got another slide that shows that, with even the possibility of dual U-turn bays. Most commonly, the truck is kept into the outside lane, but theoretically possible to have a really large loon or bulb out even for oversized loads. So I just want to put in one more reference, and our next slide talks about the resources that we have. The Restricted Crossing U-Turn Informational Guide, also available on FHWA's website. And also our Alternative Intersections Improvement Guide, as well as other informational guides on other innovative intersections. But for the rural intersection, especially on 4-lane divided highways, the Restricted Crossing U-Turn certainly emerging as a fantastic choice to help improve safety at rural intersections.
Perfect. Thank you very much, Mark. That was a lot of information, and I hope everyone learned a ton. I am going to bring us back over to a few poll questions to see how you guys will answer these. So our poll question 3 was, which of the following is not one of the 5 steps that Mark talked about? Identify your problem intersections, analyze locations to quantify and characterize problems, claim ignorance about the issue, identify potential treatments that may address the problem, select and implement cost-effective treatments, monitor over time and evaluate treatment's effectiveness, or I don't know, I don't remember. I'll give you guys just a few seconds to go ahead and fill that out. Mark, as they're doing that, we did have a few questions come in for you. One of them is, what software is available to provide intersection collision diagrams? Arizona did put a comment in there that they use the Easy Street Draw or Crash Magic for their intersection collision diagrams, but were there others you would recommend as well?
Good question. I know that there's a variety of tools out there, a variety of packages. I don't have a particular endorsement to put out there, but I think there's a variety of things out there, and hopefully at lower cost as well. But no, I don't have a specific product that I can refer you to.
Okay, I have gone ahead and ended this poll and broadcast these results if you'd like to talk about this one.
All right, very good. Yeah, so I can actually see the poll question. That's good news. So I can. So this is good. Whatever happened when you closed out the slides and put up the poll got me back in the room. So yeah, claiming ignorance about the issue. Yeah, absolutely not a good step indeed. And the vast majority of folks said that one was not one of the 5 steps.
Perfect. We do have one more poll question for everybody. R-cut intersections can have a significant reduction in fatal and severe injury crashes. True, false, I don't know, or I don't remember. And while we're giving people some time to answer that one, there was one more question that came in for you, Mark. It is, how is the adequate offset distance determined for the intersection to the J-turn so that lane changes and weaving can be accomplished by crossing and left-turning vehicles?
Yes, Patrick, that is a great question. And I do have some advice on considering that there's no one-size-fits-all answer. It should basically be an engineering decision to look at the offset, or basically the distance from the side street to the U-turn bay. And some of the key factors include things like the speeds on the main highways, at a 55-mile-an-hour speed limit, or in some areas it could be 70 or even higher. So speeds on the approach, as well as the traffic volumes. If it's relatively light traffic volumes on the main line, that basically means that there are more gaps that are available, more gaps that the vehicles can turn into. Generally, pushing the U-turn bay further away from the intersection basically would come down to, if we had a situation of needing to put in a right turn acceleration lane. So like, for example, if gaps are relatively few, or if we have a lot of truck traffic coming out of the minor street, whereas passenger cars are pretty good at accelerating quickly. Passenger cars are pretty nimble. A truck needs more time to accelerate, or more distance to accelerate. So whether I had a lot of trucks coming out of the minor street or not could make it a determination about the need for a right turn acceleration lane. If I had a right turn acceleration lane and providing a distance for a truck to gain speed, then make a lane change into the rightmost lane, then make a lane change into the left lane before coming into, say, a deceleration lane in advance of the U-turn bay. If I added up all of those independent features, in other words, if I added up the need for the acceleration length, if I added up the need for a lane change or 2 lane changes, and then if I added up a deceleration length, it can get pretty far. And there's obviously a disadvantage to increasing the circuity of that movement. So under most conditions, we try to encourage trying to keep the U-turn bay fairly close in. Now, there are signalized versions of these intersections. It is possible to signalize the R-cut. With a signal, the signal basically creates the gap, and so the U-turn location can be closer in, and somewhere in the neighborhood of maybe 800 feet even. But in most cases, for the unsignalized version, we're probably looking at least 1,000 feet, 1,200 feet, 1,400 feet may be common. But again, there's no one standard answer to that. It should be an engineered decision, and based upon the factors like the amount of truck traffic coming out of the minor street, the acceleration needs for trucks. If I don't have many trucks and it can be a passenger car, design is basically my main vehicle that I'm designing for coming out of the minor street. It may not be desirable to have the right turn acceleration lane, especially if there's adequate gaps. So that would be my advice, is to consider the type of traffic that you have, consider the speeds that you have, the traffic volumes. But just generally, if I had to give you a number, rule of thumb, probably looking at somewhere between 1,000 feet to 1,200 or 1,400 feet. Great question.
Perfect, thank you. I did end the poll question and broadcast the results if you'd like to discuss that. And then we have two final questions for you. Anyone else, if you do have any remaining questions, please go ahead and put those in the chat pod at this time. This will be the last question and answer section before we wrap up. Mark, are you able to see the results that I broadcast for this one?
Yes, so it is indeed true that the R-cut intersections can have a very significant reduction in fatal and severe injury crashes. And the numbers that have been studied so far in terms of the benefits of R-cuts kind of put them very closely online with roundabouts. And so certainly roundabouts have their application, and for the rural divided highway, say the 4-lane divided highway with high speeds and fairly minor traffic volumes coming out of the minor streets, the R-cuts or J-turns, it doesn't matter what we call them, the concept is basically the same there. The safety benefits for those types of intersections, very, very impressive. And the Federal Highway Administration uses the term reduced left turn conflict intersections as kind of our family for those styles of intersections. That they come in various forms with different wrinkles to them, but they are definitely a great safety advantage and a great tool, especially for those rural higher speed intersections. So glad to see that we had 98.6% of the folks indicate that it is true. It is indeed true.
So our next question that came in for you is, do you have any suggestions on how to stage treatment implementations so that the effectiveness of each treatment can be well understood and evaluated?
Yeah, interesting question. Yeah, because it is nice if we can kind of attribute the benefit to the specific treatment that we're putting in, and a lot of times, of course, our main goal is to bring down crashes. So if we have a high crash location, we try to put in what we can, and so a lot of times we do what's within our budget to do, but even then it often involves multiple strategies. We certainly want to solve the safety problem and try to prevent another crash. But in a situation where perhaps maybe budgets are more strained, putting in what perhaps we think would be the good starting point and something that may have effect with modest costs, and leaving that in for a period of time, but we know that crashes are random, and just because maybe even in a high crash location where say over the past 3 years or 5 years, we may even have multiple crashes at that given location. Just because we put in a treatment and 1 year or even 2 years after implementing that treatment, if there were no crashes at that site, that's not a guarantee that it was actually our treatment that led to the 0 crashes. There's the statistical phenomenon known as the regression to the mean. Basically, what that indicates is you can have a few years where we have more than expected crashes, and then just by the law of averages, the after period may have fewer crashes. And even if we did nothing, even if we didn't install any treatments, we may have seen fewer crashes occur at that location. So it can actually be very, very hard to determine what was the actual benefit from our implemented treatment. And then when we start compounding, putting in multiple treatments, it's hard to isolate, well, which one of the three things that we did was actually the one that worked? Well, the reality is maybe all three had a combined effect that was even greater than the individual parts. So it is very, very difficult to kind of ascertain what may have contributed separately. So all we can do is just gain experience over time, and so that would be my recommendation, is to try to keep track within your area of what was done when, and just monitor it over time, and hopefully we develop a better knowledge. But there's no magic recipe to overcoming some of those complications.
So another question that came in for you is, let's see, are there designs on J-turn for agricultural equipment to cross direct?
For agricultural equipment to cross directly. Well, some of the strategies that have been implemented at things like the J-turn is to basically bring the shoulders, or the inside shoulders as an extension of the U-turn bay all the way back to the main intersection. In other words, rather than have a slow-moving vehicle, let's say farm equipment, have to be exposed in a travel lane, the opportunity would exist when there's a gap in one direction of traffic, the near side, for the farm equipment to then get onto the shoulder and basically ride that down, the inside shoulder, the median side. And that way they're not exposed, they're not a slow-moving vehicle exposed in a travel lane, and basically go down and make the U-turn. And then from the U-turn location, on the right side shoulder, basically ride that to the crossover. So that is one strategy that has been utilized. Now, obviously, there's still the added circuity, that there's still the need for an adequate gap for that slow-moving farm equipment to get over the two lanes of traffic, but it does reduce their overall exposure. And just like it can be troublesome for a car or a truck to make a crossing maneuver over 4 lanes of fast-moving traffic, it can be a lot easier for slow-moving farm equipment to have that crossing broken up into 2 stages, and basically waiting for a gap in one direction at a time, and making a safer 2-stage crossing. But in exchange for that, there is the added circuity, but at least by extending the shoulder back, the slow-moving equipment is not in a travel lane. Now, with regard to crossing over on the channelization itself, well, it is possible to look at how the curbing for the channelization is designed. There have been examples where, maybe not for slow-moving farm equipment, but for emergency vehicles, for fire trucks, police, where the style of curbing is traversable, mountable at a slow rate of speed, and so. Depending upon the equipment, because there's differences in terms of what they're able to mount over, we would need or preferably desire some form of an elevated curbing, a mountable lip, but still something maybe of 2 inches or 3 inches. So it would be possible for that center channelization to perhaps accommodate something like that. The risk being, if it is too easy for vehicles, and whether it's farm equipment or police vehicles or fire trucks, there's also the risk of passenger cars driving over that as well. Now, fortunately, that hasn't been too much of a problem or an issue with the R-cuts implemented. The vast majority of drivers do execute the maneuver properly, but there is always that risk for encouraging violation if the curbing is almost too inviting. So it is a bit of a trade-off, and perhaps the better strategy for handling slow-moving farm equipment would be to have them make the U-turn maneuvers, but do so where they're not interfering with traffic. Excellent question. Any other questions?
Yeah, I was just trying to scroll through these. We do actually have two more. So the next one is, would it be beneficial to compile a list of software products to draw crash diagrams, list source and cost, and if so, is this something that FHWA can do?
We can certainly try to get back with you on that. I'd be more than happy to try to follow up with you on that. Perfect.
I can give you that information as well, so that you can get back in contact with them.
Fantastic.
The last one that came in was a quick follow-up. Because of the issues you described about difficulty attributing crashes to specific treatments, would you endorse the use of other evaluation metrics such as traffic conflicts, stop compliance, gap acceptance studies, etc., as proxies?
Yes, there's good information out there that tries to look at surrogate measures for safety. But when it comes to countermeasures that involve geometric changes, I certainly agree that reducing the number of conflict points, eliminating certain conflict points, especially crossing conflicts, I think there's good evidence that anytime we can reduce the potential for a collision to occur, we're going to have improved safety. And I think roundabouts are a great example of that. Roundabouts greatly reduce the number of conflict points, eliminating the crossing conflicts. And so I think that's a really great reason why we see roundabouts be so successful in terms of bringing down crashes. And it's the same thing with the J-turns or the R-cuts. By reducing or eliminating crossing conflicts in particular, having improved safety. So yes, as a good surrogate, certainly reducing conflict points, I would definitely agree with that.
Okay, perfect. I'm going to wrap us up. It does look like there might be one more question coming in, and if and when that does show up, I will address that one as well to you. So in this webinar so far, we hope that you have learned how to understand the concern with rural intersections, to list important references for information on rural intersection safety countermeasures, to identify intersection safety concerns from available data sources, to analyze crash patterns and assess current roadway conditions to identify contributing factors, and to select appropriate countermeasures for safety problems identified. As Mark mentioned before, we do have a couple of webinars coming up. Our next one will be July 19th, and that will be about roundabouts, and we'll have Hillary Eisbrands from the FHWA Resource Center presenting on that. We also will have an added webinar at the beginning of August that will be also done by FHWA on local road safety funding, and it will talk about local, state, and federal opportunities. The date for that one has not yet been confirmed. As soon as we do have that information, we will send it out to everyone via our distribution list, and it will also be on our website under the, Register for Trainings. And then thirdly, this summer we'll be having a Designing for Rural Bike Safety one, again also done by FHWA Resource Center. This will be held Thursday, October 16th. As always, you can find all of our archived webinars on our website. So you are more than welcome to check those out. Underneath where the link is for the streaming webinar is also a link to take our survey, and that is how you can request a certificate of completion for watching an archived webinar as well. We also want to let you know that tribalsafety.org has a Vision Zero webinar coming up on Tuesday, June 26th at 10 a.m. Pacific time. You can register at the link shown on your screen currently. Again, if you download that handout in the left-hand corner, this link is also shown in that handout. If you have any additional questions, I have Mark's email address up on the screen right now, but it does look like we have had one more question come in, so I'm going to address that to you, Mark, and then we'll go ahead and close out. So the last question is, I thought that FHWA was moving more towards assessing safety using the Highway Safety Manual and expected or predicted crash frequency more so than using crash experience.
Yeah, great question. And actually, I would say blended use of all of our tools, and the Highway Safety Manual is a great way of trying to account for that regression to the mean effect that I talked about earlier. So whereas crash experiences may just be, or crash data certainly is useful and helps us identify some issues, there's that potential problem where, say, the last 3 years may have just been statistically a high 3 years, and the regression to the mean effect and the more advanced statistical analysis is certainly methods that the Highway Safety Manual now give practitioners the opportunity to utilize. So absolutely, the Highway Safety Manual also allows folks to blend their crash data with the predictive methodologies so that better analyses are possible. So that is correct, and that the Highway Safety Manual is another great tool to help us with our analysis.
Thank you, everyone, so much for all of the questions today. I think there's been a great discussion, and Mark, thank you very much for sharing your experience about intersection safety. We truly appreciate it.
Thank you, Jamie. It was a pleasure.
Okay, everyone have a great afternoon. Take care.